algebraic limits to a number, and a lot of it you would have been writing anyway. Yeah, so and again, as always, you can stop the video when you need to. And I'm doing this on my iPad, and I can't point to things. Can I expand? Oh, look at me, I can expand. Woot woot. Okay, so the first thing you write is when you see this, and you know, this is like limit, we write this x goes to a particular number. It's underneath limit usually, but this is how math type does. So, for example, limit as x goes to 3, or limit as x goes to -5, etc. So the limit as x goes to some number of some function, always, 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 repeat yourself, always, 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 the first thing you do is try to plug in the x value. Yeah? You could get lucky, and you get your answer. And we'll talk about 4 cases that usually come up. So 4 things could happen. Yeah, so stop the video when you need to. Let's look at this first one. So I have A, B, C, D. Okay, so first thing that happen. When I plug in the number, because that's what you're doing, it's algebraic. When you plug in the number, if you get out a number, that's your limit. That's where it goes to. Okay? So again, as always, stop the video if you need to take notes before you can listen to me. Now, I'm just drawing the graphs here. You don't draw the graphs simultaneously. You do not draw the graphs simultaneously. I'm just drawing them to show you, like, and to enhance what we did last time of, oh yeah, my chubby fingers go there. So ignore the graph temporarily. What happens is you'll see this guy, the limit as x approaches 2 of quantity 3x minus 2. Okay, what's the first thing you do? You plug in the 2. You plug in that x is approaching what number? Well, let's see if I got lucky. I plug that in, and I simplify, and I get 4. So that's going to be my limit. Remember what a limit is. It's where y intends to go. It's where y intends to go. And you'll see if you graph y equals 3x minus 2, it's that graph. Whoops. And you'll see that as my chubby fingers, like we did last class, go from from either side of the graph on the graph. So your fingers are on this line on either side of x equals 2, and you and it looks like y is intending to go to 2. It actually goes to 2, and that's your limit. Okay, stop the video, take notes if you need to. And also stop and process, read everything through again. I mean, just by listening to me once or writing down without thinking, of course, it's not going to stick as well in your head. Now, listen. This is very important. I have to keep reminding, and I will have to keep reminding you. I see it every year, and it's not like I see it every year. It's I see it every year because it's like we're lazy humans and we're efficient and we're tired. It's tedious. Pero, you have to follow the mathematical form, and you're communicating to somebody very clearly. And what I'm talking about is here. You get the original problem. Limit as x approaches 2 of that. You have to. The AP exam will mark you off. I will mark you off, etc. You have to say equals. You have to have a string of equals going down of what your work is like. And you have to keep copying over this limit as x approaches 2 all the way down to the very end. Now, once I just get to numbers and no x's up here, like this 6 minus 2, I can drop that. But don't drop it before. Like, don't even drop in this line because it shows you the setup of what you did with the 2, and etc. So I get 4. That's my limit. Okay? Here's the next video. Or here's the next whatever. All right. Sometimes when you plug in, you're going to get 0 over 0. Sometimes when you plug in a number, you're going to get 0 over 0. That always, always, always means somehow there's a common factor that you can cancel out and start over again. Now, I say you factor. There's some other things going on, but for now, we'll just say I can factor it. Yeah? I mean, there's other ways I can simplify or change the equation to an equivalent one, and I can do it further. So what happens is I plug in the x value. If I get 0 over 0, I'm like, oh, I must be able to factor something. I factor, I cancel correctly, and then I retry. And what do? It's like a fresh new problem. I plug in the number, and I keep doing that till I get a number. Okay, so I'm going to be quiet right now. Follow this stream. You should write down all these red notes that I did, and you should see if you have questions of what I did. Okay, So the graph again is just for just to understand what's really happening with the algebra. If I graph these, there is a hole there. It's not defined at 2. I can't divide by 0. Pero when I go, the limit as x approaches 2, I take my chubby little fingers. It looks like I'm approaching 1/3, and I do. Okay. Third case is kind of the easiest case. If I plug in a number, if I get a number over 0, so a non-zero number over 0, I can't do anything else. I'm done. Stick a fork in me. That means my limit does not exist. Yeah? I could refine it in some cases of like it's going to infinity or going to negative infinity. Pero it's the limit does not exist. It's like the movie. You're a movie star and you're done. So stop the video, take those notes. And finally, the piece de la résistance. If I plug in my number and I get undefined over undefined, I wanted to throw a juicy one in here, and it's sort of like B. I can quote-unquote factor again, or this was where there was some sort of weird case, yeah? If you graph this on Desmos, you'd see it's this graph, and it happens to be undefined at pi over 2 and negative pi over 2. We'll refresh our memory on why. So I plug in pi over 2. Yes, you're supposed to remember what those guys are in that first red line. Yes, you're supposed to know they go undefined. And then you're like, ooh, undefined over undefined. Let me see if I can change it a bit. You use your identities to write tangent in different ways. Now look, I'm being very sloppy here. I'm being very sloppy. I should have said, actually, no, I'm not being sloppy. I take it back. This is the sine of x over cosine of x is for the tangent of x. I take it back, not sloppy. And then I use good algebra skills, cancel, and I get that. And the limit for this one happens to be 1. All right,